Hi guys, this is Miss Raina here to talk to you guys about biogeochemical cycles. Um, they're cycling what we call macronutrients, and so these are chemicals that every living thing needs. Things like carbon, oxygen, hydrogen, nitrogen, phosphorus, all kinds of things that are a big deal in all of our life cycles. Sometimes we just need them in tiny, tiny amounts. Sometimes we need them in big, giant amounts that we've got to replenish all the time. If you want to look them up in your book, you can find all four of these cycles on these page numbers. And what we're going to be studying is the way that these chemicals move through the environment, through organisms, and back all the way around. So this just kind of represents how they're all happening, and they're all happening between the environment and between organisms. Most all of them are fueled by energy transfer, now not from organism to organism, but now from organism to the environment and back. Well, where does that energy come from? The same place. It always comes from the sun. So we're going to start with the carbon cycle. Take a moment to pause the video here and draw the carbon cycle. All right, so hopefully now you've finished drawing the carbon cycle and you can see some places where humans can have some effect on this. So carbon is basically what a lot of us, or what organisms are mostly made out of. So trees are a big factor here. Trees will take carbon dioxide out of the atmosphere through a process called photosynthesis. We should all know about this, right? And they'll assimilate it into part of their bodies, into part of their actual organism. When a big area of organic matter dies, a big swamp usually, when it dies and that part of the land changes, usually that becomes an oil or a coal or a gas deposit. So things like this are actually old swamps, old trees. Um, and so what's happening when we extract that oil or that coal or that gas and we burn it is we take this carbon that used to be trapped under the ground, or it used to be trapped inside of organisms, and we put it back into the atmosphere. That's what these emissions are about. We can also have an effect by cutting down these trees, or by affecting the rate of carbon dioxide store in the ocean because the climate is changing. So here's a couple of ways that people have affected the carbon cycle. Next, take a moment to pause the video here and draw the phosphorus cycle. So hopefully you've drawn the phosphorus cycle by now, and you can tell that the phosphorus cycle and carbon cycle as well, they don't depend on bacteria. The phosphorus cycle is one of these things that is pretty much in trace amounts, but you cannot live without it. Plants cannot live without it. This is part of your DNA. And so in order for a field of agriculture, for example, or something that's going to become a forest, for it to thrive, it needs lots and lots and lots of phosphorus. Very little of it can be dissolved in water. Most of the time, it's moving around through the air, or it's been deposited a long time ago. And when I say moving around through the air, that's what you were breathing in over the summer when you got all those allergic reactions to the Saharan dust. That's what's carrying phosphorus. And so that comes in big wind currents. Most of the time, it just gets deposited over long, long periods of time, and humans can have an effect on it by extracting it from the rock, adding it to fertilizer, and then it gets dissolved into the water where it normally would not be. From there, it starts to feed algae. They start to kind of like go nuts and overpopulate in lakes and rivers. And we talk about that in terms of eutrophication. So bacteria are not a big deal here. You usually don't find phosphorus in the gas state. It'll travel around as dust in the atmosphere. It's very, very slow because it depends on rock formation. But what we do is we take it out of the rocks and we put it into fertilizers, because most soils are deficient, and plants, like our agricultural plants, need it. Okay, take a moment here, pause the video, and draw the nitrogen cycle. The nitrogen cycle includes terms like nitrogen fixation, assimilation, nitrification, denitrification. Those are all terms from your vocabulary, okay? And the big time first step that everybody needs to be very, very familiar with is nitrogen fixation. because what's happening here is in order for your body to make protein, and in order for plants to make protein, they need nitrogen. Well, it turns out the air you breathe in and out is full of nitrogen. It's mostly nitrogen, but you can't use it to make protein. Only bacteria can. So bacteria can get it into the form that plants can use to make protein. You can eat the plants, and then you can grow your muscles. Otherwise, you're in trouble. You might eat the cow that ate the plants, and you can grow your muscles, but otherwise you can't do it. Very, very small amounts are made by lightning fixation, and in some cases in very, very high temperature combustion, like in emissions from a factory or from a car, we can have a little bit of nitrogen fixation happening. So we can get kind of like some nitrates in the atmosphere because of combustion. Okay, so let's break this down a little bit. This is big time dependent on bacteria. Humans can affect the nitrogen cycle by contributing to acid rain, doing combustion in cars or in factories, by taking fertilizer and contaminating soil or groundwater, um, and also through deforestation. So fertilizer is a big deal here because that's what makes the plants grow, but it's also what makes the algae grow when that fertilizer gets into the river. Nitrogen fixation is that important first step of taking the nitrogen out of the air and making it into a form that plants can use to make us proteins. Only bacteria can do this. Sometimes lightning does it, sometimes high temperature combustion, but mainly only bacteria. Nitrification is when we get ammonia to turn into nitrate. So assimilation is when the plant roots absorb the ammonium, the nitrogen in the form of ammonium, and turn it into their own molecules and their own organism. Ammonification is what happens when, again, look, there's the bacteria. They make ammonia basically. So they take the complex nitrogen compounds and decompose them. Denitrification is when all of those ions get converted into nitrous oxide, and there goes the nitrogen gas back out into the atmosphere to start the whole process again. At this point, congratulations, you are done learning about biogeochemical cycles. Join me again later for, I don't know, it looks like it's going to be biomes. Thanks a lot.